The future of electricity sales, intelligent forecasting with neural networks. This video is based on research titled Forecasting Electricity Sales using the Artificial Neural Network Backpropagation method. PTPLN is a company engaged in the provision of electrical energy in Indonesia, and one of its objectives is to meet consumer demand for electricity. PLN is required by law to provide consistent and reliable electricity. To plan for the future, they need to forecast sales accurately. Accurate forecasts help in infrastructure planning, pricing strategies, and managing energy supply. The data used in this study is historical data on electricity sales obtained from the Planning and Trading Division of PTPLN, West Java Distribution Unit. The variables in this study are electricity sales in kilowatt-hour units, taken from May 2012 to August 2022. From the plot, the electricity sales data pattern is not linear, where there are changes in the up and down pattern fluctuations that tend to follow an upward trend. It was non-linear and non-stationary, which made traditional models like ARIMA less effective. PTPLN has estimated the projection of electricity sales in the future, which is called the roadmap. However, there are still some weaknesses, where the roadmap is still based on annual data trends and has not implemented monthly forecast calculations in projecting electricity sales realization data. Artificial Neural Network, AN, is a system that processes specific information with performance characteristics similar to biological neural networks. Based on a study conducted by Arungpadang et al., 2018, it was found that electricity consumption estimation using ANN is better able to follow the trends of historical data compared to traditional forecasting methods, which tend to produce more linear results. So, how the ANN works. The first step in ANN forecasting is to form an architecture on the input, hidden, and output layers. In monthly data with a period of 1 year, the forecast input use consists of 12 inputs according to the number of months in one period, year. The input is in the form of data from the previous 12-month period. Determining the number of hidden units is done by trial and error based on the smallest MAPE value obtained from the testing process later. The output used in this forecast is one output, namely an estimate of the amount of electricity sales, kilowatt-hour, for the next 2 years. Normalization is carried out using the min-max normalization technique, which then produces a value scale on the forecast data that is between the range 0 and 1. The following table presents the normalized data of electricity sales. The normalized data is then divided into training data with a proportion of 80% and test data 20%. From the compilation of input and output data that has been done previously, 112 forecasting data were obtained. The data is then divided into training data and test data, so that the training data in this forecast is 90 data and the test data is 22 data. There are 3 main stages of network training with backpropagation, namely the feed-forward stage of the input training pattern, the calculation and backpropagation stage of the error value, and the last is the weight adjustment stage. The training and testing process is carried out using the neural net package in our software. The learning rate used is 0.01 with a maximum iteration of 100,000. The activation function uses a binary sigmoid function, or, in our software, is called logistic. Weight initialization is set to a random value according to the backpropagation stage. The training and testing process will stop after producing a small error value. The best backpropagation architecture model is determined based on the number of hidden units that have the smallest MAPE size. Based on the results in the following table, the number of hidden units that can be used in this forecast is 7 units. Because with 7 hidden units, it can produce the smallest test MAPE value compared to the others. Thus, the best backpropagation architecture model can be obtained in this forecast, namely the 12-7-1 model. In the right image there is a red dotted line that shows the forecast results using the 12-7-1 architecture model against actual data. Based on the 2 images, it can be seen that in general the forecast results on the training data and test data have followed the actual data pattern. This is proven by the MAPE value obtained, namely 3.179% at the training stage and 2.965% at the testing stage. Based on the following table, the forecasting results for electricity sales in West Java fluctuate according to historical data on electricity sales in the previous period. The highest sales forecast value occurred in November 2023, which was 4,693,436,129 kilowatt-hours. While the lowest forecast value occurred in May 2023, which was 4,153,269,389 kilowatt-hours. By using artificial neural networks, we can make more accurate and consistent monthly electricity sales forecasts. Thank you for your attention.